thank you for joining us, Al. It's a real pleasure.
No problem. I have all the time in the world.
So I'm just going to start off here. Albert, can you tell us a bit about yourself?
What would you like to know?
Oh, you know, the usual, just short and simple. When you were born, stuff like that.
Well, I was born in a city called Ulm. It is in the kingdom of Württemberg in Germany on March 14th, 1879. But we soon moved to Munich when I eventually began my schooling at the Luitpold Gymnasium. Then we moved to Italy and later I was studying the Swiss Federal Polytechnic School in Zurich, Switzerland. Well, then I had a doctor's degree and we moved to the United States for political reasons. I don't really want to get into that. I was always interested in physics and in early stages of my life, this passion of mine was shown.
How so? I mean, I always thought you were, school incompetent.
These are just rumors. I was top in class. This is where my talent flourished. People recognized me for who I was. Anyways, in the US I developed all these different theories about physics and chemistry and finally received a Nobel Prize for my work in the photoelectric effect in 1905.
What's that?
Well, essentially, if light hits a metal object or surface, energy is added to the atoms, and since the atoms now have too much energy, they must release some of the energy to become stable again, so they emit the electrons. Do you understand?
No, not really.
What do you wish to know?
Well, pretty much your contributions on how we view the atom today.
So what I described was certainly one of them. My main contributions on this topic are to the quantum theory and the photoelectric effect, as I have just described.
Fascinating. So can you tell me a little bit more about this photoelectric something?
Basically, a colleague of mine, Max Planck, observed that when light shined upon a metal surface, it released or emitted electrons, or electric current. This current coming out in small bursts, but he did not know what was causing this phenomenon. I figured that the molecule's energy had to be quantized, or have certain constant values, so I began developing a formula about this constant, later known as Planck's constant. The formula is H, or Planck's constant, equals 6.26 times 10 to the negative 34 times the number of joules, the unit for measuring energy, times the number of seconds. This was to determine the minimal amount of energy needed for a quantum state. I predicted through theoretical physics that light, like energy, also comes out in short bursts or in small packets. I call these packets das Lichtquant, or the light quantum. Of course, for this to happen, light would have to have the properties of a particle. The measure of light was also called a photon later on, from the Greek word for light, phos.
Wow. Well, I mean, I don't really get most of it, but it sounds very, very intriguing. Now, what's all this quantum theory about? What's it mean?
It basically means using mathematics to describe certain dual behavior of a particle or matter and waves or energy. In 1900s, myself and Planck stated that light energy is absorbed and emitted, goes out or in short bursts of energy. These were known as quanta, hence derived from the name quantum theory or quantum mechanics. Later on, another colleague of mine, Niels Bohr, took our idea and used it to form his version of what the atom should look like. I like to think of it as mine and Planck's contribution to a greater good. So like I said now, in the Bohr model of the atom, there's a possibility of electrons jumping from one level to the next as they lose or gain energy in discrete amounts. In fact, because of this, that it was thought to believe that light in the shape of particles, not waves.
Alright, so then really, is light particles or waves?
Difficult to say, it is, for light exhibits the properties of both particles and waves. Some say that it is simply both a particle and a wave. Haha, who knows? In fact, it may even be true that light is made of something man has never seen, never touched, never heard of. Ingredient X.
Fascinating. Well then, we're out of time here, but before we go, I gotta ask you one more thing. What's up with the Manhattan Project?
Shh. Top secret.